Okay, so Taylor method, mm, okay. Let's start from the initial problems. Y prime is equal to f of x comma y, okay, and then y of x0 is equal to y now. So initial problem is given, okay. So we'll assume that f is continuous, and its derivative is also, f and a partial f over partial y is in continuous. C. C of omega. Omega is domain. Domain of f. Oh, give me a second. Or you just say the set of all points x comma y where x is between 0 and b, and the y is negative infinity to infinity. Okay, this is just represent the domain of f. Okay, and then we can find the f derivative of f as many as partial derivative. We can find out as many of the partial derivative of f as possible. Okay, it's needed. So now then, let's say the pi of x, the exact solution. Okay, of the integral problem. Okay, and then pi prime. Then what? Here, then pi prime of x is going to be f of x comma pi of x, isn't it? Because pi, pi is the exact solution in the integral problem. Then when you plug in pi into the differential equation integral problem, the derivative pi must be equal to f of x comma pi, right? That's what we got. That's what we got this. And then the pi of x naught is equal to y naught. Okay. Okay. Pi of xn must be equal to y sub n. Yeah. So for discrete point x0 or x naught to xn means the just grid point. We can say that. Okay. So maybe this is x naught. Okay. Here's x1 through the here's maybe xn. Okay. So here's xk, and then here's xn. Okay. So for each discrete point, evaluation pi at each discrete point must be equal to the exact solution at each discrete point. Okay. So now we're gonna derive the Taylor series for pi of x. About the point x sub n. Okay. So that's gonna be the pi of x is equal to what? Pi of xn, right? Plus, and then h times, you see that? Actually, pi prime, right, of xn, right, times x minus xn, isn't it? And a plus, and a pi in the second derivative, the parenthesis 2 in the parenthesis represents the order of derivative, okay, over 2 factorial, right, and then x, and then xn, okay, and then x minus xn squared, plus through the what? Pi of n x n. Let me use the other one. K m. Oh no, what letter L over L factorial, right? And the x minus xn to the L's power and a plus something like this. Okay. Yeah, yeah. I think that's enough. Here now let's say h if we say h represent x minus xn, then what? This becomes what? H. This becomes what? H squared. This becomes h to the l's power. Okay. Now this one in Taylor series, what that is called the remainder theorem, right? Remainder term. Right. So then we can use the up to L minus let me use L minus 1th term as approximation of pi of x. Right. And then this one gives us the error. Right. This is called truncation error. Because we truncate at the up to the term before this term. So now pi of let me just rewrite this one. Okay, so this is equal to, by the way, this is where the pi of x is going to be pi of xn, right? And plus, you see that pi prime, because pi is a solution to the integral problem. So pi prime going to be f, right? So I'm going to replace the this one by this f. And then second derivative is what? F prime, right? Derivative f with respect to x. So let's find out. Then pi is xn, and also what? By the way, since pi is the exact solution, pi of xn must be equal to what? Y sub n, right? Because pi of x, see here, pi of xn is y sub n. Because it's a solution, that must be equal to y sub n, right? So we got the y sub n, y sub n, and the plus, right? The pi prime is what? F, right? F, and then here's h. So let me write h first, and the f of xn. N comma yn, right? So this is equal to what? That is equal to pi prime of xn. Okay. That is equal to what? Pi of xn. Right? Now plus, okay, here's the problem. What's the second derivative of pi? Okay, since the second derivative of pi must be first derivative f with respect to x. So since the f is a multivariate function, I mean f has two independent variable x and y, and the y is a function of x. So using the chain rule with a partial derivative, then this turns out to be partial x. I mean partial x plus partial f partial y times dy dx. And now plug in xn into x, then we're gonna get this, and then since y prime is equal to f by the differential equation, so we got this. Because of that, right here, the second derivative of the second term, I mean, sorry, third term of the Taylor series becomes this one times a over 2 factor times h squared. Okay, so we got but this is too long, right? So let me let's say this f2 is defined by that. Okay, f2 is defined by this because this is too long expression. F2 of xn comma, and then in. Okay. So now then okay. So from here, then we got the h squared over 2, and the f sub 2, and then xn comma, and then pi n, right? But pi n is equal to what? Y sub n. Okay. So you can put a y sub n instead of pi sub n, because each mesh point, I mean grid point, the value of pi must be equal to the value of y. So, and then plus in that way, we can find out the third derivative of pi, right? In that way. I know this is too long expression. I'm not going to do this anymore. So plus and the h to the p power over p factorial, and then f sub p. Okay, so f sub p means what? That means the p derivative of f with respect to x. Okay, x n comma y sub this right here. So as you can see that up to hold on. So y sub n plus h times f x sub n comma y sub n. What is this? This is what Euler method. Okay. So and then now then let's see. So Euler method what? As you can see, the Euler method has order 1, which means the b equal h. Right? And then if you add the second term, then the order will be b equal h squared. So as as you add more terms to find out approximation, y sub n plus 1, you're gonna get the convergence order of convergence will be increased when you add more terms. If you just use the first, the second of the third term, then you're gonna get the order of the 3, which means the b equal h order squared, b equal h squared. If you add more terms, 1, 2, 3, 4, then you're gonna get the b equal h to the third power. Here's the problems. It's not easy to figure out f sub 2, f sub 3, f sub p. So we normally we don't just add terms. It's not that simple, because the first derivative f was kind of it's kind of simple, but this one, the second derivative, is not that easy. Why? Because this is you need to take a derivative of this guy. Let me see that. This one and this one, you need to apply the product rule in these terms, and then also you have to apply the chain rule, and the blah blah is so is tedious. So anyway, so let me rewrite this one using the letter y instead of pi is equal to y sub n plus and the h times f of x sub n comma y sub n. So that's Euler method, okay? Then h squared over 2 factorial, and then f sub 2 xn comma y sub n plus blah blah blah, and then h to the p's power over p factorial, f of p, then xn comma y sub n. That is called the Taylor method of order p. Okay. So that is called the Taylor method. Okay. So this method has a second. The AP, the order of convergence, which means that the rate of convergence, let me just say CO and V stand for convergence. BOH to the P spot. Okay, let's keep in mind this. Let's take example. Okay, so determine the recursive formula. for the Taylor method. Of order 2. Okay. Yeah, so normally we use the Taylor method with the order 2, okay, up to 2 for the integral problem. So y prime is equal to sine xy, and then y of 0 is equal to pi. Okay. So see, from there, lies f of x comma y is what? This is a sine x comma y, x times y. Okay. Any initial conditions, yeah. So right there, given. Then what are you gonna do? We need to figure out f sub 2, right? F sub 2. So the f sub 2 of x n comma y sub n. Okay. This is equal to what? You see right there, right? So pauser. Let me copy this one. Copy. Paste. Okay. So this is a y sub n, sorry. This is y sub n. And this is y sub n. Okay. Y sub n. So partial derivative f with respect to x gonna be what? What's that? This is equal to. What's the derivative of sine of xy with respect to x? What's that? Just cosine xy? Y times cosine xy? What about, really? We need to figure out, we need to figure out this one, partial f, partial x equals a partial f, partial y, right? We need to figure out that first. Implies, what's that? What is this? Yeah, this is right, y times sine xy, okay? How about that? Or cosine, sorry. This is x times, cosine xy, right? Okay, so when you take a derivative, partial derivative of f with respect to x, we consider y as the, I mean, we're not just finding, we're not just finding partial x, partial y. We're gonna find out what? Weird one. F2, which is the partial f, partial x. But when you find a partial x, since y is the function of x, so we need to, that's what we got this formula. And then here, partial and partial x and the partial and partial y, we consider x and y as the just independent variable. Okay, which means that when you find out partial and partial y right there, don't just consider y as a function of x. Yeah, eventually we do. That's what we got the f. But when you find out partial and partial y, we just consider y as an independent variable, not a function of x. Okay, because we already considered y as a function. That's what we got f right here. Okay, so don't be confused. You may say that, okay, so when you find partial x gonna be y times cosine xy, then what? Times y prime. You may say this. No, don't do that. Okay. So now, so we got this, and then yeah, we got this. So we just put them into here. So we got a y sub n, right? And the cosine and the xn times y sub n, right? Ooh, and the plus. And then this is gonna be xn, right? Times and then cosine xn times yn and then f of what's f? What's f? F is sine xn and y. Okay. And then let's see, this is equal to what? The sine and 2 times x and y and over 2, right? Because of the addition, addition rule for the triangular, trigonometric identity, right? Okay, so now I think it's done. Yeah, okay. So now we plug in this one into the Taylor's Taylor method. Okay. So this is step 1, and then step 2. We find the recursive formula. So x of n plus 1 is equal to x of n plus h. And then y sub n plus 1 is equal to y sub n plus h times sine, right? X n y n, and then plus h squared over 2, and then y sub n, and then cosine x n y n, and then plus, see, y, I just copied this. I'm just copying that. And then xn over 2 times sine 2xn yn. I think we got the formula, recursive formula. Recursive formula means that we can find the formula is using the formula we can find the value or approximation sequentially, okay, continuously. So then y0 is what? y1 is equal to what? y0 and then plus h times the sine x0 y0 x0 times y0 plus h squared over 2 and then y0 and then cosine and then x0 y0 and then plus x0 over 2 and then sine and then 2 times x0 y0. And then once you figure out y1, yeah, and then what is x1? X1 is x0 plus h, right? And then we find out y2. Okay, and then we move to next time step. X2 is equal to, here's not time step, just next step. X2 is x1 plus h. Then we find the y3. Like that. Okay. So as you can see that it's not easy to find, it's not straightforward to for finding the in the Taylor method is these f sub p. Okay, so the p is increased, then it's more difficult to find out this one. For this, even that example, the average sign right hand side of the differential equation is sine x times y. That's simple. That's why it was relatively it was easy to figure out the f sub 2. But normally in reality, in practice, the f of x comma y is not that kind of easy. Okay, it's normally it has a complicated form that had so that's a Taylor formula.